We discuss about equivalence partitioning. Right? So equivalence partitioning is a black box testing method that divides the input domain of a program into class of data from which test cases can be derived. Right? So equivalence partitioning means what? So what you will be doing is that you will be having a set of test cases, right? So what you are doing is that you are partitioning into equivalent or equal levels of it, right? And when you are partitioning it, and then based on the partitioning, you will be creating the test cases, right? So for the test cases, right, what you have to do is that you should have the minimal number of test cases, and you should be able to test all the test cases. This is what the major requirement of equivalence partitioning. So equivalence partitioning is actually handshaking with boundary value analysis to get the minimal number of test cases, right? As I already told, if you're having minimal number of test cases, you will be completing it as early as possible, and also with the help of the minimal number of test cases, your performance will be good. It means that the maximum number of test cases will be covered, right? All the errors will be identified, right? That is what the equivalence partitioning. So equivalence partitioning is actually handshake with boundary value analysis. So these two methods should be combinedly used, right? That is what the point. So the next is actually the equivalence classes may be defined according to the following guidelines, right? So they have given some guidelines. I will come back to the guidelines with the help of an example, right? So let me show you an example here. So I'll remove everything, right? Let me take a table of it, right? I have a e-commerce website, right? I have an e-commerce website, and then I have introduced a module called offers, right? Offers. So there are 3 offers I have given. That is, $1 to, or sorry, say 5% discount, 10% discount, and 15% discount, right? So if the purchasing of the user, right, our customer, is from $1 to $100, then it is 5% discount, right? So if I am making the what is that? If the user is making, the customer is making the purchase from $101 to say $200, right? $200. Then it is going to be 10% discount, right? So likewise, $300 and above, right? So greater than say $300, or let me say $300 to $400, right? And above $400, that will be invalid. That will be, so purchase not allowed for this particular thing, right? So above 400, so above $400, it is going to be invalid, right? And below $1, right? Below $1, it is going to be invalid, right? So what I did is that I have partitioned the test cases. I have partitioned the test cases. What kind of partitioning I have done? So 5%, 10%, and 15%. So for 5%, $1 to $100. Likewise for each and every percentage, right? And then this is the invalid case. So what I will be doing is that what I have done is that I have partitioned the datas, right? So I will be picking say test cases, or 3 to 4 test cases from here, 3 to 4 test cases from here, 3 to 4 test cases from here, right? And I will test it. How I will test it? So for example, I will take $10, $10, and then I will test it whether it is taking, or whether it is generating 5% discount or not. That is one test cases, right? Then I will take say $90. If I am using $90, whether 5% discount is allocated or not, right? So likewise for each and every partition, right? I will be using 3 or 4 data and I will test whether it's properly working or not, right? Fine. Now the next is I will be testing 2 more test cases. There's invalid test cases. So I will give less than 1 values, any values less than 1. I will be giving greater than 400 any values, right? So for these test cases, right, it should be invalid, right? So this is what, right, equivalence partitioning, right? So you have a set of test cases, you have partitioned it, right? Based on the partition, right, you are doing the test casing. This is what is called as equivalence partition, right? Let us discuss the guidelines of it. If an input condition specifies a range, that means, so here I have given a range, right? 1 to 100, fine. So if the input condition specifies a range, 1 valid and 2 invalid equivalent classes are defined. Okay, so 1 valid and these are the valid things, and these are the invalid things, right? So 1 valid and 2 invalid equivalence classes are defined. If the input condition requires a specific value, right, 1 value and valid and 2 invalid equivalents are classified. See, for example, let me do one thing. So, say for example, I'll be having, say, a value here. This is the value I have to test. If it is having 500, then it means that it is invalid. Right? It is invalid. Then what I have to do? I have to let me see another test case. Right? Let us forget about this. Right? So let me do one thing. I'm having a value 500. If it is 500, then the temperature, or say it is 500, the temperature is high. So a simple example. Let me say it is 100. If the temperature is 100, say it is a valid temperature. Okay. So what you are checking is that you are checking the input condition requires a specific value. So 100 is there. So what you have to do is that you have to test for 3 test cases. What is that? Let me give you a table here. 3 test cases. What are those? Right. So test case 1 is. So test case 1 is less than 100. You have to take one value less than 100. Greater than 100, you have to take another value. These 2 are invalid condition. And what is a valid condition? 100. This is valid. Right? This is what we have mentioned. If an input condition requires a specific value, 1 valid and 2 invalid equivalence classes are defined. Right? This is what the second condition. 1 valid and 2 invalid equivalence. Say in this example, what? 1 valid, this is 1 valid, and 2 invalid. These 2 are invalid. Fine. If the input condition specifies a member of set, right? So for example, member of set in the sense, say in a set you'll be having various values. So you have to check for 1 valid and 1 invalid equivalent classes are defined. If you're having a Boolean condition, then 1 valid and invalid, that is true and false. That's it. It is a Boolean condition. No? Fine. So likewise, you have to partition it, and then you have to test it. Right. Now, normally what happens is that, right? Let us move back to the example which we discussed just now. Right. This is the example we discussed just now. Right. Normally, when you're testing, right? When you're testing, most of the time, the developer will miss the test. Will miss the what is that logic, right? In the boundary value, right? See, say for example, here less than 1, here starting from 1, right? So in this case, up to $0.99, it should not work, right? And that is, it should show invalid value. And in $100.99, it has to show 5% of discount. because when it comes to 101, what happens is that it is going to be $10. So this such kind of testing you have to do it, because most of the developers, right, they may have missed it, right? So they may have missed it. So such kind of testing, if you are doing it, you will be able to easily identify the errors, right? Fine. So that is what is called as the boundary value analysis. This is the boundary. This is the boundary. This is the boundary. What is the boundary for 5%? 0.99 is one boundary, that is the lower boundary, and 100.99 is the higher boundary. It's the maximum boundary, right? So likewise, you have to identify the boundary value, and then you have to analyze it. Then you have to test it. That is what is called as boundary value analysis, right? So boundary value analysis leads to a selection of test cases that exercise bounding values, right? So boundary value analysis is a test case design technique that complements equivalence partitioning, because as I already told, right, you won't be able to do a successful testing with the help of equivalence partitioning, right? You won't be able to do a successful test of boundary value analysis. Both the things you have to combine it, right? Complements, that's what complements, just a handshaking, right? So both the methods, what is that? Equivalence partitioning and boundary value, both the methods, you have to complements, right? You have to use it to get the best test case output, right? So ultimately, what is the aim now? With the help of these two methods, you should be able to minimize the test cases, number of test cases. That is what the major aim of it. These are the three major guidelines for boundary value analysis, right? As I already mentioned. So what I told is that, so let me show you that. For this case, what is the boundary value? What is the boundary value here? So here the boundary value is, what is that? 1, you have to give the 1, right? 1 is the boundary value, right? Up to 0.99, it has to work for 0.9, it has to work for invalid, right? And for 1, it should be, right? 1, it has to go to the, right? It has to go to the next one, right? So here, the lower boundary value for this particular thing is 1. If it is 1, right? If it is 1, it has to give 5% discount. If it is $1, it has to give 5% discount. This is a valid case, right? Valid case. For $100.99, for $100.99, it should be valid. It should be valid for $5, 5%. It should be valid for 5%. Here, what is the boundary value? 101 is the lower boundary value, right? And what is the higher boundary value? 200.99, right? It is going to be dollar, right? Let me mention this so that you won't be able to get confused, right? Right? Fine. So these are the boundary value, right? These are the, let me show boundary value. Also boundary value, right? So likewise, here what is the boundary value? 300 is the boundary value, is it right? So 300 is the boundary value, and 400.99 is the boundary value. It's the boundary value, is it right? It's well and good, right? Excellent. So 300 to 400.99 is the boundary. Likewise, here in this case, starting from 400, it should be invalid. Starting exactly from 4. So these are the boundary value data. So you have to create the test cases 1, 2, 3, 4, 5, 6, 7, 8 test cases you have to create, right? And then 2 values in between these two values. So 8 plus 2 plus 2, 12 plus 2, 14. So totally 14 test cases. If you are doing it, you will be able to, and that is the program, you can able to test for all the values. That is minimum number of test cases 14. With the help of this 14 test cases, you will be able to test all the values. That's it, right? This is what is called as boundary value analysis. The guidelines they have given, right? If the input condition specifies a range boundary by values A and B, test case should be designed with values A and B just above and just below. See, just above and just below. Like this we have done now, right? Like this, just above and just below the A values A and B. If the input condition specifies the number of test case should be developed that exercise minimum and maximum values, right? So input condition specifies number of values. If you have a number of values, say 1 to 100, then identify the minimum and identify the maximum value of it, right? And if the internal program data structures have prescribed boundaries, say a table defined limit is 100 means, for that you have to find the boundary condition, boundary test case condition. That's it. So ultimately, this example shows you that what is the boundary value analysis, how to identify the boundary value analysis, right? So if this is the range, then you have to test for the starting and the ending value, right? And this is the boundary, then you have to check for exactly below the value. This is exactly above the value. This is what they have given this in the guidelines for boundary analysis. This is what we have. Very important topic. What is that? Equivalence partitioning and boundary value analysis.